This is David Asarno, and I'm here with Dr. Pompa. We are here for Cellular Healing TV, episode 46. Dr. Pompa, can you believe it's been 46 episodes of Cellular Healing TV?
Yeah, it's hard to believe. I'm going to get closer to my camera. Yeah, it is hard to believe. And here I am in Jackson Hole, Wyoming. Let's see if we can show some of the
I can see the moose.
pictures.
I can see the moose lamp behind
exactly.
you.
There behind me. Yeah, this is cowboy town. I mean, you can just tell by these magazines sitting there. Cowboys and Indians. Of course, it's a ski town, right? I mean, ski and so I'm here for business and always a little pleasure. But no, here we are in Jackson Hole, Wyoming, and always amazing snow and amazing animals and moose and elk. But we're here for an amazing show and an amazing topic, David, in my mind.
And today, and no better place to talk about epigenetics than Jackson Hole.
Why is that?
I have no idea. It just came out. Because you're there, I'm here, and that's the topic for today. So why don't we talk a little bit about epigenetics? And I know that some of our viewers know what it is, and some people are saying epigenetics. I've heard of it. It's been in the news recently, or it's been in a trending topic of conversation. So what is epigenetics?
Well, look, epigenetics, think of it as what your genes are expressing. Meaning that, here's what you have to understand. Humans are 99.999% the same DNA. I know that sounds hard to believe. Meaning that, David, we all have basically the same genes. That's why we don't look like rabbits. So, or we don't look like moose, right? Like the moose you see behind me, or elk. We actually have 99% the same genes. So then you would say then, yeah, but why are we all so different within the human race? Well, that brings up a good point, and that's the point of epigenetics, meaning that really it is our epigenome. I'm going to give you an understanding. Now, this may help some of you and not others. Think of your genes that we get as humans as your hard drive. We get that from our parents. That is our hard drive, like a hard drive in the computer. The epigenome is your software. Okay, so really that's where all the changes come from, right? That's where, we really makes us who we are. So yeah, we inherit a certain set of genes, but really it's the epigenome. Certain things get turned on and certain genes get turned off. And therefore we sit here today is literally an expression of our genes. Now there's two major things that do this. Basically our environment, like our habitat, so to speak, right? And obviously, things that we do, our lifestyle. So we'll say our environment and our lifestyle, our habitat, where we live, whether you live in Jackson, the East Coast, whether you live in a polluted environment or a clean environment, whether you live in a stressful environment, a non-stressful environment, or whether you eat bad, good, exercise a lot, and exercise little. All of these things determine who you are because they change your genome for good or for bad. Therefore, David, if you eat good, you express good genes or things good from your genes. You get the best of your genetics. If you eat bad, you get the worst from your genetics. So that's what the epigenetic is. Epi means on top. So literally, it's this covering of the gene that is really what changes the hard drive down in the gene. And your genes are either expressing good stuff or bad, David. So I don't know. I mean, you probably have 10 questions there. Let's get them to understand that before I move on.
So you're right. You can see me writing questions based upon what you're talking about. One of the things you mentioned was turning on, and genes turn on and turn off. Now, I know that we've had this conversation before in previous episodes of Cellular Healing TV, and yet someone may be tuning in for the very first time today. What does that mean? So how by changing your environment, changing how you exercise, how does that give the ability to turn on or turn off certain gene expressions of how we're showing health-wise or weight loss?
Well, okay. Let me start with an example that we talked about before, and it was a study out of Stanford University where they took two groups of mice. They were identical twins. They separated the identical twins, so that means they have identical DNA. And they put one set of brothers and sisters in one group, the other set in another group. They fed them identical. They exercised them on their little wheels identical. So they basically created the same environment and habitat, right? And then what they did is they exposed one group to a chemical. Matter of fact, a chemical called BPA that we're very familiar with. Mostly we're getting that from cosmetics, personal care products, things we rub on our skin. Of course, you can get it from plastic, especially hot and styrofoam. I've watched David do that once. And,
we did that last week, and that's what you were talking about, BPA. Got it. Now I get it.
Yeah, okay. So, yeah, I mean, BPA is a chemical that's mostly found in plastic. But look, this could be any chemical, David. This study, they used that particular chemical. Heavy metals, same thing.
I had to have my coffee con leche so much that last week. So there you go. My excuse.
That's right. Okay. Give it. But I always say that's an exception. I don't ever make. I'm not going to drink coffee out of styrofoam and get all that styrene. Styrene's another chemical that's in, obviously, styrofoam. That's the word, right? It, too, can change genes on and off, okay? But, you know, it turns, chemicals like that, they turn good genes off, David, or genes that we have in us that keep us thin. We have genes in us that keep us healthy, keep our insulin, our energy metabolism, our fat metabolism running and working normal. When that gene gets turned off, now we don't metabolize energy normally, and we can start to gain weight. We have genes that literally can express certain things like obesity. So back to the Stanford study. So the chemical turned on something called the agouti gene. The agouti gene is a gene that does, in fact, make you obese, as well as other factors. It predisposes you to heart disease, thyroid issues, other problems, okay? So when they turned on the gene, remember, two groups of rats here. They turned on, actually mice, but they turned on the agouti gene in this group of mice by using a chemical. Fed the same, exercised the same, gave them a chemical. It turned the gene on. They became fat and obese, despite their diet, David, despite how much or how little they exercised. Now, the bad part is their next generation, even though they were not exposed to the chemical, they inherited the gene, the agouti gene turned on. So guess what happened when they were little teenage mice? They became fat and obese with a predisposed, their hair became yellow, you know, thyroid issues, you got it. So they inherited the gene turned on, they became obese without changing their diet. This is happening generation after generation after generation. These types of toxins that we're exposed to, our parents were exposed to them, they affected our DNA. So now we wonder all of a sudden why, with just one more little stressor in our life, why all of a sudden now we have a certain condition like Hashimoto's, a thyroid condition, or why we can't lose weight. See, because that gene was turned on. Sometimes it just takes one more stress or stressor to trigger that gene even further and express another condition that we're not happy with. So, you know, that's really how it is. Now, so the best part, I think, about the study is that they were able to turn off the gene. And then the next generation was born normal, right? And they weren't born with that predisposed gene. See, David, you know, look, in ninth grade, they weren't going to let me on the wrestling team because I had high blood pressure, just like my mother. Okay, that was in ninth grade. Today, you know, here I am, much, much older, obviously, and I don't have high blood pressure. Not on any medication. Unlike my mother, who took medication for high blood pressure her whole life. I would have went down the road. So I'm older without high blood pressure. What changed? Well, the gene got turned off. But, you know, it did take some time, David. You know, I remember even eating healthy and still being slightly high on blood pressure. And it wasn't until I did a certain amount of detox that I was able to turn that gene completely off and have zero high blood pressure. So, I mean, that's the point, is that I had my mother's gene, no doubt about it. Something turned it on, obviously my lifestyle. And therefore, you know, it wasn't until I was able to turn that gene off that I actually got the blood pressure within normal range. So, you know, again, the nice thing is we can change our environments, we can change our habitats, we can change our lifestyle, change our level of toxicity. And what we're going to talk about here in a little bit is changing other things like exercise also is something that helps a lot. David, there's a product in that study, and I want to leave that study, but the Stanford study, they gave the mice, because I think our viewers are going to say, well, what did they do to turn it off? They gave our mice something called methylation or methyl groups. There's a product called MORS, M-O-R-S, that is a methylation product. And this methylation product, we have in it the very same things that they used in that study. These methyl groups, they gave to the mice in abundance, and they turned the gene off. And basically, that's exactly part of what we do today with very challenged people who have very challenging conditions, even weight loss resistance, which is very challenging, thyroid conditions, autoimmune conditions, but also changing diet, reducing stress. All of these things play into turning off your bad genes. So, David, the old dogma was we just got the genetics of our parents. If they got diabetes, we're going to get it. Whatever you're going to get, right? I mean, think about it. I mean, didn't at some point you believe that at a certain point?
Of course. Well, actually, I don't believe that I believed it, but everyone always says, well, if so-and-so had this, tell me about your parents. Well, I always told the doctor, it doesn't matter what my parents had. Well, there's hereditary things that will happen, and you know, obviously, there's still a lot of people who believe that.
Yeah, right, and it's really not true. I mean, listen, we do get that hard drive. However, again, it's whether you turn them on or turn those genes off, and the great part is you can't turn them off. But doctors don't understand this. This is new science. You hear me talk, David, about, you know, there's this massive gap between what's happening in this exciting world, you know, of research, and this is one of these exciting worlds in my mind. Is the study of epigenetics is amazing right now. You know, there was the Human Genome Project. I think it was in 2012, and I mean, just brought out absolute amazing science, and yet the treatment world, the doctor world, however you want to look at it, they're not doing anything with this information. You know, I believe we're trying to close down that gap of what's happening in science and what's happening in the treatment world, because this is exciting stuff. You know, I mean, but yet doctors still believe that you got a disease, you got cancer because your parents got, you know, cancer. So few diseases are purely genetic in nature. You know, when you look at a complete chromosome error, that's a genetic disease, right? I mean, that's something completely different here. But everything that we're talking about and dealing with here, you know, whether it's thyroid, diabetes, weight gain, weight loss, I mean, this is all epigenetics. I mean, all epigenetics. Whether that gene is turned on, we need to turn these genes off. That's the discussion we need to be having.
So what is the first step? So if we look at someone's watching today saying, okay, the challenge that we have is we live in an instant gratification society. People want what they want when they want it, and they want instantaneous results. And as you said, you know, it took a lifetime and possibly even generations to get the gene the way it is. What is the first step that someone should take to get their health back?
Curse your grandparents because it wasn't their genes. It was what they ate and what they did. True. I mean, it is inherent about it, but you know, we need to change, obviously, for our next generation. David, the first thing we do is we definitely want to change our environments. You know, we want to be in a toxic-free, stress-free environments, because you know, when we look at these studies where they take identical twins and we realize, why does one get cancer and the other not? It's typically their environment. It's typically how they live their life. Put yourself in stress-free environments. Well, most people are going, well, crap, I can't change that, right? You know, okay, so let's talk about what you can do today.
How can you deal with the stress so that way it doesn't affect you negatively?
Absolutely. You know, here's the irony. I talked about that product MORS, methylation, being properly methylated. You know, that's important because we need these methyl groups to actually turn on how we adapt to stress. So we needed to activate our stress response. So if you're properly methylated, you respond normal to stress, and you adapt. I said on the show last week, all disease really boils down to the ability or the inability to adapt to a stress. When you don't adapt, now you're developing disease. Let's be more specific. Now you're turning on bad genes, right? So that's really, you know, a continuation of last week's product. I said this. Everyone, think of this, folks. We all have different size buckets genetically of being able to tolerate stress. a lot of it is how blessed we are with our methylation ability. But let's imagine all having these stress buckets, okay? So I'll pick this up as my example, okay? So this is a cup of organic coffee that I got here in Jackson Hole. But look, so this is our stress bucket. All of our stressors go into that, David, right? So here we're going to put all our emotional stressors in there. Now, emotional stressors can go away, right? And then, but all of our chemical stressors, they tend to bioaccumulate and fill this bucket up. Stress, stress, stress. Now, some of the emotional stressors, they don't go away, and it goes up even further, and then it goes up even further. And now it's right near, and just a little bit of stress. If I almost spilled it, see, because the line is right here. And when that overflows, now we have a problem, right? Now it's overflowing. So let's empty it down to here. Let's say the fluid line was here. Now I could stress it a lot more and not overflow. We want to empty our stress buckets. That starts to turn off our DNA. So taking methyl groups helps because it helps us adapt to the stressors, even the chemical stressors, and it starts to empty that bucket. Detox, cellular detox, something that I'm a fan of, helps empty the chemical stressors out of this bucket. And therefore, we can adapt to greater stress. We can start to turn off those genes. So when this bucket overflows with any type of stressor, remember, your body reacts the same physiologically to every stressor. I have an alarm going off, so I apologize. Hopefully it goes off. So David, when this bucket overflows, we start to develop disease.
So you were talking this morning about a magazine. Can you hear me?
Yeah. Okay.
You were speaking this morning about an article in regards to epigenetics. What is in that article? I'm curious.
Yeah. No. Great topic, because in this is becoming a great, exciting topic, right? And there was an article in New York Times this week, and if I could just show you, but it was a great article. I lost it again, but anyways, I'll find it. But anyways, the article, I wanted to read you the topic here. It'll come up in a second. Right here, New York Times. And the article states that, well, I had it, and then I lost it. Right here, how exercise can change your DNA. Let me see there. Let's see if you can read that. How exercise can change your DNA. And then there's a picture of people exercising on the bike. You know, so the thing about the article, David, I think it was neat is, you know, obviously we understand that if we do certain types of exercise, we get a great benefit for weight loss, and especially, you know, high-intensity exercise. Well, one of the reasons now we understand that this type of exercise can actually turn certain genes on. Matter of fact, it affects the epigenome in a place called enhancer genes. Okay, and the thing in this study that they found was that it enhanced genes involving carbohydrate metabolism or insulin, and all these things to do with how our muscles use energy, aka burn fat. Okay, so we know that when we exercise, we can turn on genes and make us efficient fat burners. We can turn on metabolism and also better use of insulin. So that's telling us that that's why exercise affects diabetes. We really didn't understand why exercise, especially high-intensity exercise, affects diabetes for the positive, but now we know, because we know that it turns on these very specific genes that have to do with how we metabolize energy and how we utilize insulin and how we break down fat for energy. So, David, here's what they did in this study I thought was interesting, because the reason exercise, this has been difficult to study, is because so many things affect our genes, our epigenetics, right? So before we would say, well, how do we know if it was exercise, this exercise, that exercise? Because look at their diet. We couldn't control their diet. What if it was this? What if it was that? So what they did in the study is they exercised one leg of this group of people. So they got them on a bike, and they only exercised one leg, whether it was the left leg or the right leg, able to see the genetic change in the left leg, for example, versus the right leg. And then they were able to isolate what genes were actually turned on and what genes weren't, because they only exercised one part of the body. Pretty cool.
Very cool.
Yeah, this opened the door to see this is what this type of exercise actually does. Pretty neat.
Wow, that is very cool. So let's talk a little bit about the best kind of exercise that if we're going into the time of year right now that people start thinking about exercise and especially during the holidays. I mean, I've read that people eat, you know, thousands upon thousands of calories on the holidays for whether it's Christmas, whether it's Thanksgiving. Um, what type of exercise is best? You mentioned it a little bit, but can you go a little bit
Yeah,
deeper?
I recommend just spinning with one leg on a bicycle, just one leg.
I don't know if I can do that. So what else can I do?
Well, if we want to emulate that study, no, I'm joking. Obviously, that did come out in New York Times, but that was just released in Epigenetics, which
Sure.
is an amazing review. But anyway, so the scientific study's out there if you want to read it. You could just Google epigenetics, and I'm sure you'll come to their site, or New York Times. You'll see the article if you Google New York Times. It was out this week. So, anyways, David, what type of exercise? High intensity exercise definitely turns more of those genes on that we look at as far as weight loss. So if we want to lose weight and turn more of the genes, the good genes on that help us become better fat burners, utilize insulin more, studies show that the high intensity, you're going to activate more of those genes. So therefore it's going to have a better effect on diabetes. It's going to have a better effect on weight loss. So high intensity means if you've watched my articles on burst training, read those articles, watch those videos. Burst training, that's where we get our heart rate up to at least 80% of our maximum. We go hard for at least 30 seconds. It could be 2-3 minutes. And then we take 2-3 minutes off, recover, go high intensity again, because when you go that high intensity, you just can't keep going, right? So it's called interval training, high intensity training, where we do intervals of high intensity, rest, intervals of high intensity, rest. I'm a strong believer in. Look, I'm a cyclist. I love endurance racing, and there is some benefit there too. But as far as weight loss, diabetes, absolutely, the high intensity works better, turns on the genes better. And then, David, obviously, when we're looking at what we can do, yeah, we can increase our methylation. That's the mores. Detox, cellular detox. Watch our past shows. Because really the whole cellular core that I write about, my 5 R's, R1 through R5, that is true detox. Fixing the cell, that's key. And in a future show, I want to talk more about that because we haven't in a while, David, so please write that down. Because I want to really show some people what we're doing at the cellular level to really what, true cellular detox looks like. Because there's so much confusion that, hey, this colon cleanse, or I did this cleanse last week. Every one of those cleanses is typically a colon cleanse. Not that there's anything wrong with that, but it's not true detox. Okay, method that we use in cellular detox. And again, the more you watch my videos, the more you'll see that. But what we will do, stay tuned for that. That is going to change your DNA. R number 2, folks. Read my article in R number 2, and that R number 2 is regenerating your cell membranes. We know it's the cell membrane that actually turns the genes on and off. By the way, it's the cell membrane is where they say holds the intelligence. The cell membrane is what looks at your environment, communicates with your environment, says good or bad, and then it changes the genome. So I know that's very complicated, but all I'm telling you is this. On every cell, there's the membrane that surrounds it, and then there's all these receptors, hormone receptors. But think of these things as the antennas. They go, ooh, toxins or good stuff, right? And they communicate with the environment, and then they change the genome in the nucleus of the cell. So now it can turn it on for good, or it can turn it off for bad, or turn it on for bad, off for good. You get my point. So it is the cell membrane that you need to pay attention to. Read those 5R articles. My 5Rs is a roadmap of how to fix them. You have 5R articles. So really taking the cellular core, which is what I call, that's the core. I mean, we have a lot of different products for each R on how to fix a cell, but that's the core. Read them. You'll understand how to fix your genome, because that is really what it's about. The cellular core is about changing epigenetics for good, and that's the point of the show.
And for everyone to view the articles, go to www.drpompa.com, drpompa.com. Dr. Pompa, any final thoughts that you would like to leave our viewers with today?
Yeah, no, I mean, I think that we know why exercise works, but it's not just exercise. It's not just diet. It's not just, our environment, our habitat, and our lifestyle. We sit here. You watch this show right now as you view it as an expression of your DNA. Bottom line, it's either good or it's either bad. The best news is you can change it. But you have to change your environment. You have to change, that means the toxins, the stressors. Empty your stress buckets emotionally, physically, chemically. You will start to adapt better to every stress. You will eventually start to change that DNA. But take control of what you can change now. Exercise, start doing it. Make it a goal in January. Eating better, everything that we say, taking the cellular products, that eventually will change the expression of your genes. And then you will sit here a year from now, I promise you, expressing differently, expressing better, not expressing thyroid conditions, weight problems, etc., etc. That's a choice. I believe it. Some of it perhaps isn't. Certain stressors you can't avoid. Change the ones you can.
I love the message. Basically, you have control of your life. You have control of your health. Change the food that's coming in. Excuse me. And you can, a year from now, you'll be a different person. I love it.
Hey,
Dr. Pop, yes.
When we first met, I want to use you as an example of that. When we first met, you were from some bad stuff from your DNA. You were overweight. You had things, we'll just say it. You had other things going on. But that was an expression of your DNA. As you changed, as you hung out with us longer, you started changing your lifestyle, right?
Mm-hmm.
You changed what you put in your mouth. You changed how you exercised. Am I right on all that?
Well, yeah.
You changed it all.
I was a vegetarian when I did a year and a half of vegetarian when we met, and I thought grains was fine because they were vegetarian, and I was gaining weight.
Yeah. Yeah, exactly. And you were expressing a lot of bad stuff, and that would have continued. But you changed, and now you're expressing thinness. You're expressing fit. You're expressing, more energy, more brain power. That really is an expression of what's coming out of your DNA. Pretty cool stuff. But listen, it does start, with, changing what we put in our mouth, changing our lifestyle. So,
It's a commitment. It's a commitment.
Absolutely. Absolutely. But exciting science. I'll keep you abreast on the science. But that article out this week, exercise, can change, especially that high note. See you next week. And oh, by the way, next week I want to preview the show. I think we're going to have a patient on of mine. Well, I call him a client. I call all my people clients. He had stage 4. He literally was the worst pancreatic cancer. Listen, folks, he's not only a survivor, which doesn't happen. He's thriving. Wait till you hear this story. Pancreatic cancer is a death sentence. They gave him a death sentence. Wait till you hear this epigenetic story. That's going to be next week.
Awesome. Thanks, Dr. Pompa. Thank you, everyone, for tuning in. We'll see you next time, 10 a.m. Eastern Time, Friday morning. Thank you.
See ya.